So let me introduce myself. My name is Arkady Kistanov. I am the founder and CEO of kTool. And today is the first workshop about our new web version. We are adding some functions every week. So even for those of you who maybe already seen the app, you can find something new and something cool. So I will run fast throughout how the app works. So we're using simple Vacaros files with very weak dampening here to check the data. I will give you some examples on the base of 29er datasets, and I will show you all the functions. And I had a request from a lot of users about to give some hints how to analyze maneuvers and what exactly we can look at, to get the performance, to get some bits of information about the performance. So I just uploaded the file. What you can see is that I was using the speed filter. Speed filter is, I believe, the easiest way to cut off useless data from your analysis. And I normally use the speed just under our upwind target speed. Okay, so this is a data file from 29ers. As I already said, the analysis was done. We can see that the wind direction was found pretty clear. This is a Garda Lake. We can see it, and the training was done with Zora. We can check the exact wind direction here. And so algorithm calculated the general wind direction from 177 degrees, which is pretty accurate. So what we want to do, we want to reset the bearing. So now we have the wind direction from the top. We have the track with all the marked maneuvers and with wind directions at this time and at that moment for this boat calculated. So you can see the arrows on every maneuver. We can switch it off. Let's go a bit deeper about what the map can do. So first of all, every maneuver is clickable. So you can click on that maneuver. You can see entry speed, exit speed, minimum speed, distance passed over the plus minus over the maneuver. Let's say it's 20-second window, and your average VMG. And as soon as you clicked on any maneuver, you can see how that maneuver compares with your average. We have separate text jibes, and marks. Marks are now just clickable on the map, but we are not yet analyzing them. This is the future. Okay, so yeah, we can switch between track and tail modes. We also can put the range for y-axis on the graphs. I hope I told it. And we can add videos. Pretty simple. Just choosing the video and they will appear. In our case, we doubled it already. So if you have few overlapped videos, you can switch between them. As well, if somehow it happens that your video doesn't have an offset, a proper offset, you can just move the video on timeline and reset offset if you need. We work with the video the work with the video is quite simple. We can zoom it in, we can zoom it out. If we zoom it in, we can move video, we can mute it or unmute it. We can slow it. We can slow it down maybe if we want to look at some details. We can accelerate it if we want to skip something. So the cool features of one of the very cool features of our player is distance passed in time. So let's say we want to set the range between 60 and 40 meters passed for the last 20 seconds, and we can see that like the real advantage one boat is getting over another, and we can see how much the decisions cost for the boat. So for example, here 2 boats will do the tack one after another. Let's look at it. And one boat will do a better tack. So the yellow boat is doing definitely good tack. We can see that they get the maximum speed just before the entry of the tack. The minimum speed is quite low, 2 knots, but in less than 5 seconds they rebuild the speed to the maximum. While violet boat, purple, whatever you want, they enter quite nicely, but they are not accelerating at all after the tack. And we can see how the violet boat is actually losing distance compared to the yellow boat. So coming slightly backwards, we can see that the boats were passing on average like 53, 55 meters in 20 seconds before the tack. And the green boat lost around 8 meters on the tack, while the violet boat keep losing because they haven't got back to the speed immediately after the tack. The same thing helps us if we want to look, for example, on the top mark rounding. Yeah, let's go a bit more here. 76, let's say. On the top mark rounding, we can clearly see how much one boat lose compared to another, on hoist or drop or doing any type of maneuver. And we have VMG 20 meters distance passed, which is kind of the same thing, except of here program is also calculating direction to and relative movement to the mark. So it is mostly more VMC than VMG, but we can clearly understand if one boat is doing right decisions or wrong decisions. Any questions about that part? Yeah, we always can switch between map and video. We always can switch between track and tail mode, and in future our plan is to add some modes for the mapping, showing how fast the boat was going, how good in VMG wise it was going, and our idea is, after you uploaded a certain amount of sessions for one boat, we're planning to add, let's say, performance score, Whoop-like performance score, when you can see if the boat was performing good at that point or not really good. The next thing is maneuvers. So we can clearly see here every separate line. Every separate line on maneuver graph is your tack or jibe. If we switch between them, and you can switch between different variables. For example, speed over ground, SOG speed over ground, super simple. Turning rate, true wind angle, heel, which is I believe the most important thing for small boats. Yeah, if you have load sensor, you can use load. You can check the distance loss, the absolute distance loss for the boat. So it is good to compare boat with itself, because the distance loss is calculated on the entry speed. Of the boat. So this is how many meters boat is losing compared to itself. If I want to compare different boats, we prefer to look at distance passed. So we can see that here's the distance passed between two boats is actually very, very small by the end of the tack. but in the middle of the text, the distance is more than a meter, which already matters for such a small light boats. We also can look at VMG distance loss and VMG distance pass. So we can see that violet boat is actually on average doing better, performing better in VMG wise, almost 2 meters better, 2 meters better tax. So let's run a bit deeper with this exact text and how do we want to analyze it. So we always look from the start to the end of the tag. Normally, as more speed you have in the entry of the maneuver, as better maneuver would be, simply because you can keep more inertia into the face of the maneuver where the boat is without any pressure pushing you in front. So what we're looking at with what speed the boat is actually entering, and what we're trying to get maximum speed just before the boat starting to rotate, no matter if it's jibe or tag or mark rounding. Yeah, so we clearly can see here that the violet boat goes with a bit more speed, but just before the entry of the tags, the speed of the both boats is quite equal. What else we can say here is that the minimum speed for violet boat is slightly higher, like 0.2, 0.3 knots higher. And the third big thing we can figure out is the acceleration of the violet boat is actually a lot worse than for the green one. And we want to figure out what exactly we have to change. Yeah. So for the green boat, we want to have a bit more speed all the way before, and we want to have a bit higher minimum speed. For the violet boat, we are looking for acceleration on the exit. So looking here in true wind angle, yes, we can clearly see that the yellow boat is going just a bit higher, maybe 1, 2, 3 degrees higher than the violet boat. This may explain why the boat is going slightly flatter and why it has slightly less speed. So what we want to tell is just to go just 1, 2 degrees, lower to keep in order to keep this a bit higher speed. Yes. Then the next thing is, and the big difference here is the middle part of the tag. So actually the tag itself, we can see that the violet boat is healing the boat a bit earlier and generally starting the tag a bit, starting the tag movement a bit earlier. So probably the sailors are moving into the boat earlier than on the green one. And the exit part, we can see that the boat actually spends around 2 seconds. Boat actually spent around 2 seconds with almost 10 degrees of leeward heel on the new tag. Why it might be? Probably the main is normally too tight, so the boat is not flattening immediately, and this prevents boats from fast acceleration. We can see that the yellow-green boat starts. So the green boat starts tech a lot later. So the crew is definitely entering the tech later, and we can see that there is almost no time with a lot of hills, so the boat flattens very fast. Next thing is how flat the boat is after the tech, and here there is a certain difference in 1.5, maybe 2 degrees but I would say that both of them are pretty flat. 3 degrees of leeward hill on the exit is a pretty nice, hill. What else we can say? We also can say that the green boat is exiting maybe also like 1 degree lower on average, and this is probably also helps to accelerate a bit faster. Yeah, we also can look at, for example, turning rate, which is really nice and really interesting. So turning rate in degrees per second show us how the bow of the boat is moving, and yeah, we can clearly see that the violet boat starting to rotate a bit earlier, and it never rotates as fast as the green boat. So this is probably why green boat lose more speed in the middle of the tag. So maybe we want to have a bit smoother rotation. Yeah, and we also can see that there is a moment of stabilization for the violet boat. At some point, the rudder is going under 0. It means that at some point boat starts to laugh on the new tech, and this is what we want to avoid. And this is probably associated with too much heel. Yeah, and this is exactly what happens. So this is more or less how we are doing the analysis of the boats. If we only have one boat, for example, so we don't have, imagine we don't have second boat to compare with, we always can switch up top 25% of our maneuvers VMG-wise, and we can see here how our average, compares with our best. And this is exactly what we were talking for yellow boat. It is more speed on the entry and higher minimum speed. Yeah, this is exactly what we were looking at. We told that for yellow boat it might be a bit more, smoother movement, and this is also what we have here. Any questions on that thematic? By the way, you can always share the session, and I will send you the link in chat. So this is a private link which you can share with your sailors or your friends if you want them to look at your data files. They will see exactly the same as you are looking at now. In order to be able to see this session, you have to be registered, but you don't need a subscription. So this is a data file from two boats, and it is quite straight. We can see now that we will be able to see here that if we're looking at course over ground, down here on the straight lines, we will see that everything is quite precise, because this is course over ground, so actual course. Also, if we switch on the winds here, we will see that average wind direction is 177. By the way, if it's wrong, you can just put another number, for example, 180, and it will recalculate everything. So you always have an option to adjust it. And also, if you have wind direction, so kTool.hu, so if you have wind file, you can just add wind file, or if you will have the wind in your main file, it also will appear. So here we can see that the wind direction, calculated wind direction, is 178. But if we will look at arrows, which shows you the wind direction at the moment, they will show quite often completely different numbers, because on Garda Lake the wind is not coming always from the same direction. So yet direction is vary. And if we will switch here to truant angle, we will see that truant angle will vary on 2 tacks, which is not super true, but it gives us, I mean, when you're comparing few boats, it gives us more than enough information for training, because for us it is important to compare, boat with boat who was performing better, and we can clearly say that on port deck, yellow boat, yes, on port deck, yellow boat on average was going 1 degree lower than violet boat, and as well we can see that yellow boat on port deck was going flatter, like 2 degrees flatter than violet boat, and the outcome of this would be that yellow boat was going 0.2 knots faster on average on port deck. Yeah, this is what we are looking at, and then we are opening the videos, and we look at the general graphs, and we try to understand, we can pause it, we can look at the tuning, we can look at the sales. So here I was looking at the sales shape, and I definitely had some comments here, and then we jump to another boat, or yeah, we can. So then we can jump to another boat and understand what's going on here. So after you have the statistics, you can pretty easy find the proof of your words. I mean, proof of the statistics using the video. That's the idea. So yeah, looking at the port side, yellow boat was going slightly lower, a bit flatter. The result, they were a bit faster. So I believe that's it with analyzer. There is another cool tool coming, kTool, good, coming pretty soon. So this is a recant and cell shape analyzer. Let's go first with the cell shape analyzer. So you just choose a photo of your cell, you put the dots, and it automatically makes the curve where you can see the camber. So the camber is the amount of depth of your cell in percentage. Here it's 11.8%. Camber position, the forward depth, aft depth, and twist. This is pretty classic cell shape analyzer. What we can do as well, we have a really nice cool thing which names Rig Analyzer, and who was using for people who was using our desktop version, the first version. It is quite common thing to compare how the boats are actually, how two boats are actually tuned and rigged. What is easy we can do? We just put the perpendicular from the mast foot, and we add one more line from the mast foot to the top of the mast, for example. Yeah, and we can go to rig data, and we look at the angles, and we look at EF, EI, EF, EI, 25 degrees, GH, GJ, 18 degrees. They're already chosen, so you don't have to look at all of them. But what is a cool feature which we found out just some time ago, we maybe will we'll change it so we can zoom it in, and we also can, we actually can use the cell shape analyzer to analyze the curve of the mast. Yes, finish. Yeah, and we can see the rake. We can see the rake. We can see the mast band and everything we added to chosen. So we can see, yes, there is a different rake on two switches. On one switch it's 18.5, on another it's 25.1 degree, and we can compare the bend of the mast between two sails and two boats, and it will be completely different. I just don't want to do the second one. Yeah. So this function will be added probably by the end of this week. It's almost ready, and of course you can export it, and it will appear as a data file as a screenshot in your download folder. Yes, I believe that's it. The race analysis is coming in June. We in our desktop version, we already were able to detect the starting lines from Vacar's instruments, and as you can see, that the marks are already recognized on in our app. So it's a matter of time when we will automatically recognize the races, and when we will automatically recognize the races, and when you will get the full review of how many percentage, what is the percentage of the race of the leg you were going, and how. I can also show you some example of what is coming. Something like, so we also believe that we will generate something like this. So this is actually a breakdown about where the boat has started, what was the distance to the line at the start moment, what was the delay speed on the start, how much distance you passed, how much distance of the length of the leg you travel, so 147 or 149%, time on the port deck, time on the starboard deck, and so on for every leg of the racing course. But this is coming a bit later. Yes. So the philosophy of the tool is that you get the debrief in under a minute. This is the main philosophy of the tool. We don't want to make it too complicated. We want to keep it as easy for sailors and coaches as possible. And when we are adding any functions, we only try to put it in when we are sure that it's not making the process too complicated. That's the idea.